Hey friends, I think we're live. Thanks for tuning in today. This is going to be part 2 of controlling lights with blocks. Should be really cool. Let me just make sure all my stuff is all set up here. Cool. Let's see. We should talk about what we're going to do, and we can kind of look at the progress we've made so far, and then we can dive into like some more UI stuff. I'm Andrew. You're watching Code Gets Creative, where we do all sorts of creative coding and kind of fun coding that we might not otherwise get to do. So it should be fun. Let's switch over. Have a look at what we made last time. So you'll remember that we want to make an app where we can navigate to a URL in our browser, and we'll be able to drag these colorful blocks using Blockly, right, or Scratch. And we'll snap them together, and they will be able to control a Philips Hue light. So it'll look something like this in the UI. In terms of like the architecture, it'll look something kind of like this. So we'll interact with the UI. That'll all be like Blockly and React. That'll talk to a server that's in NodeJS. And that server is going to talk to the Hue bridge, which in turn will talk to a bunch of lights. And so yeah, there you go, like that. Here's what we currently have for our UI. You'll notice a couple of things have changed a little bit since the last stream. So we've got this cool top bar now that like says what it's about, but there's also this run button. You'll also notice that we've got a few different blocks here, but maybe most importantly, I actually took a bit of time and wired up just a very basic backend server to start actually processing these. So let me show you what that looks like. So you can see there's this like starting block. When the program starts, do this stuff. And so let's start out by just turning the light on, and then maybe we can wait for a little bit and turn the light off. Just go with that for now. You can see that back here, sitting on my little keyboard, got a Philips Hue light, so we can use that to test. Click run, turns on, waits for a bit, turns off. Perfect. You'll notice that when it turned on, it turned red. Let's change the color to something else. So how about we turn the light on, then we'll set the color to, let's see, 120, should be green. And we'll wait for a bit, and then we can like change the color again. Let's see, what is like magenta? That's gonna be, it's probably gonna be like 330. Try that. Good like vaporwave color scheme. Turn light on, set it to that, wait for a bit, change the color, wait again, turn the light off. We'll run that. Light turns on, turns green. Yeah, nice, I got that color right. And it turns off. Sweet. So yeah, you can see that our app is starting to kind of come together in a basic way. Pretty cool. Let's do a quick tour of the server. Gonna look at what that's doing. You don't need that more. Okay. So let's see, we're looking at some of the UI and then some of the backend. You remember that the UI, yeah, we've started to plug in sockets. So we'll get to that today. But in the meantime, our app, right, our app component, it's got a top bar, and when you click the run button, it's gonna handle run right up here. And then the editor is now contained in its own component. See that's going on. And let's see if we open up the editor. You can see that is where we're actually defining blocks, right? We do that here. We're defining the toolbox. So you can see, let's run back over here. We've got colors and timing. And so you can see we have a colors category and then a timing category. And each of these is a block. And fortunately, we've got TypeScript happening here. So we've got some nice type checking going on for all this JSON. That's going to help us do the right things. That's cool. And let's see, this is actually not doing anything right now. So comment it out. What it's going to do though is there's actually a way to highlight whatever current, like you can say this block is active, and then you can highlight it. And that'll be really cool because then when we click run, we'll actually see the program step through and like call each of these blocks and execute each of these blocks. So that you'll see this synchronized with what the light's actually doing, and that'll help people feel more comfortable with what their programs actually do. Good. Okay, so we talked about the UI. Let's talk about the server. Close some stuff. Here's the server. This is written in it's NodeJS it's Express. So Express is a great, easy way to set up an HTTP server. It's also using socket.io, which is a cool abstraction on top of WebSockets. So it lets us really easily create a real-time connection between the client and the server, and we can do very quick communication in either direction. We can actually push information from the server down to the client. So when we click run, boom, we're gonna just send a message to the server, but then we need to send a bunch of messages back as each of these things happens. That's what will actually power that. Now, notice also that we have these two imports from inside the server. There's this concept of an interpreter and then an environment. And so we're building an interpreter from scratch. I didn't get out my Dragon book. I actually don't have that famous book, but there is another good website that is kind of a book that's a work in progress that I should pull up here. And that was some of the inspiration for how this is written. We're going to need to evolve this a little bit as we add some more powerful things. So as we add control flow, like looping and conditional flow, we'll have to tweak some of this, and I think that book will actually help. Let me pull that up. Crafting interpreters. This is an awesome book. You can sign up for the mailing list if you want. The author also writes some books about like game development, cool things like that. But for the purposes of our project, the chapters that are especially relevant are 7 through 9. Probably 7 through 10. We'll get to 10 eventually. But yeah, these have been really helpful. So let's look at how that stuff is running. So let's open up the interpreter. Oh. See that over here. Actually, let's check this out. So when we run the server, we're saying, hey, initialize the environment, and then once that's finished, run the server. So in order to initialize the environment, let's see, that happens here. You'll notice that this is calling the Node Hue API from that script we looked at last time, and we are connecting to the bridge that's in my house, the Philips Hue bridge. So once we have this client, then we can call other functions like turn the light on, or turn the light off, or set a color, right? And it'll do all that stuff for us. So that's kind of the very edge of when our program starts talking to the third-party code. This kind of manages that. But this is also the interface where we can interpret different things, right? Because the interpreter has a reference to the environment and can talk to it that way. So here's the interpreter. When we create it, you'll notice we have an instance of an environment that we save away. And then notice this, we have this.handlers define blocks. So we define the blocks on the front end. We also define the blocks on the back end. Two different sets of modules. They look kind of similar to each other. Let's look at that. You'll notice it's really just like a list of a bunch of instances of classes. So we just do those up. And they all implement this iBlockHandler interface, which looks like this. So every single block handler can get its type, which is going to be a string that's like set color, and then evaluate. And evaluate is the thing that actually like operates on that block and does something, or eventually will return something, right? Promise of type, some return type. And so that's in abstract, that's what this is allowing us to do. So we create a bunch of these, and these are all defined here. So let's look at turn the light on. Turn the light on happens to correspond to light on block. So it's a class. it implements I block handler. Get type corresponds to light underscore on. And that is going to match up with some UI code. So if we go into blocks.ts on the front end, here it is. So here's where we're defining that block, and then here's where we define how to actually evaluate that block. In this case, we call the environment .light on, and we wait for that to happen. So once the light has taken its time to fade on, then this function will return and the interpreter can keep going. So let's look at that. Let's see, set program. This is where we say like, hey, here's a bunch of XML, and then run. Yeah, here we go. While there is a current block that we have a reference to, then tick, which basically means like do the next thing. And so, let's see, await handler.evaluate. That's the core guts of it, right? We basically say like, grab this current block and then evaluate it in the context of the current environment. And then we get the next block based on it. Cool. So that's working. We have a very, very simple program, a very, very simple app. Do stuff. And like we can click run, you can see stuff change. Feels really good. So now I think we should kind of zoom out and think about like where we want to go next, what we want to do from here. So let's see, let's pull up this file. This is a fun little life hack that I like to do. You'll notice this is a file just called notes.md. I didn't want to check it in because it's kind of just my little scratch pad of stuff that I'm currently working on. So I'm keeping it separate from the README, which by the way needs some instructions later. But you'll notice I've got this kind of to-do list. So you'll notice we've kind of got this queued up, like highlight blocks as the program runs. To do that, set up the test environment. Yeah, I really want to do that for when we have like control flow. We want to make sure to not break this thing as it gets more and more complicated. And then we can start building out new blocks that are like loop n number of times, or loop forever, or if something is true, then execute this. Start getting into that. But I think before we get into that, we should probably iterate a little bit more on basic blocks. Because I think that what we have right here is like, I think we've like, I don't think I know this. I know that I basically took set color and simplified it down as much as possible, just for the sake of getting a basic thing out the door. Same with timing over here, like wait for 1.5 seconds. You'll notice that like these are just text fields. You can just type right in it, but there's not a space to like plug in a block. So I think we need to change that so you can plug in blocks. But there's a question of like, well, what is a block? Like where do the blocks start and end? So we should do some iterating on that, and then we can work on the back end to catch up with that. On basic blocks, evaluate on server. Cool. So I think we can do some of that. So let's see if we can highlight these blocks. This should be a good project. We've already got a bit of a head start. The reason I say that is here's my terminal. We've got the UI running over here, and then the server running over here. And so let's get this fired up. It's compiling with TypeScript right now. And it just ran. And so when I click this, it's going to send the program as XML text, and then it's going to immediately start running it. So we'll see what the console looks like. Run. You can see that's changing. And so a bunch of stuff just started. And it's finished. Yeah. So here's what this looks like. First, it says new connection. That basically just means the UI has connected through WebSockets. Setting a program. Here's that big XML. So you can see like start, light on, set color simple, or with each of these inputs. Blah, 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 and then run. So at this point, we're ticking through each of these blocks, right? And this is just a bit of debugging to kind of help me. So you'll notice, like, here's the ID of the block. And this is the thing that we need to send back to the UI and say, like, hey, this is the current block. So we need to pass that into WebSockets. Okay, go through each of that. Set color, this is just some more like debugging, right? That we're calling the right thing on the Philips Hue bridge. And eventually we come to light off. At that point, we're done. Cool. So yeah, let's see if we can get that going. Here's the interpreter, and each time we tick, we know that this is the block that we're operating on. Here's the ID. So I think right here, actually, let's see, we could potentially throw an error. So I think we want to do immediately before we evaluate. So we need a way to emit events out of here. The reason I say that, I want to keep it abstract. Like I don't think we want the interpreter to have like a direct access to socket.io. And part of that is just to kind of keep the code clean, like keep this isolated from all the third-party stuff. It's got like XML DOM, but who cares? That's just for like parsing. So I think we want to keep it separate from how the server actually talks to the front end. But the other reason is if we abstract that a bit, it'll make it easier to test later. So we could do something like this. And we need to come up with a type that we can pass out here. So let's figure that out in a minute. Let's see, we basically want to say, and we're kind of like coding in reverse here. We want to say this dot emit event, and then what do we want to put in here? I think it'd be cool if we do kind of like, we do some JSON sort of, I'm thinking like Redux style, or more generally like the command pattern. So we could do like type, and we could say like current block, and then we've got a payload inside of here. So you could say ID is ID, just like that. So cool. Now this needs to have like a reference to listeners. So it would probably be something like this dot event listener. I don't think we need to have like an array of listeners. That's probably fine. And I mean, event listener could just be a function. So I think we just pass in event. It'll look kind of like that. Let's come up with an event type. And it is of type string. So yeah, what we got here. Interpret event is an object containing type, and it's got to be this string literal. Anything else that doesn't match, and ID is some sort of a string. Oh, cool. So then this should be an interpreter event. And then this is going to infer the type, so that's great. We don't have to do any more work there. Okay, and then we need the concept of an event. So, io.emit. Yeah, you can see I kind of started that here. So, what if we do something like this? Interpreter.set event listener, and then we can pass a function that receives an event. We have to export this type events. I'll have that. And then this doesn't actually exist yet. Let's create that. I think we can put it like up here. This is gonna be. I want to give this a type. I think. And this is going to be a function that receives an event of type interpreter event and returns void because it's going to do a side effect. So I think it should look like that. Set event listener, we receive an event listener. It has no return type. We would just say this call it set event listener. Listener means that it needs to exist here. Listener, that is of type event listener. Makes sense? And then we need to initialize it. I'm gonna say this event. Oh. Okay, so we're telling it here that it has to exist. You'll notice that we're letting some of these other things be nullable. You know what we could do? Yeah, we could just give it a no op function. So it ignores the argument and then it does nothing. And this is very low overhead, so I think that should be just fine. Here, at the event, I think we're ready to wire this up really. So let's just grab this. There. Now you'll notice that io.emit, there's some like high level type. Based on kind of fooling around with it a little bit, I think it's going to be easiest if everything is just message, and then we handle it like within the JSON itself. So that's kind of my plan. So really, we just need to do that. And yeah, we can keep that there. So we've now handled this to-do. Give it a try. So save some files. Restart the server. There we go. Then so hold on. Are we getting CORS errors? Good. And you'll notice that I just lost my program. That should work. I'm going to click run. We can look at the console in both places. Run. Look at that. We got a current block, which is this guy. Status is running. Go and get this one. And that should all line up with this. We tick. Sure enough, that matches just great. On and then this. Ooh. Okay. it's a little awkward that like this is kind of all by itself. I think really like we shouldn't have any of these all by themselves. The interpreter should admit that. So let's do this. I think you can actually, yeah, you can have a leading pipe character. Kind of love that. And so be able to take this. Notice how we're calling run and then we emit that right after. So we basically, we want to do it right here. Oh yeah, this is that event listener, right? Oh, no. Init event. And then we're going to pass in type status running. That's that. And then I think we should have another one that's like type status. What should we call it? Stopped? I guess we could also do like type status ready. I think that's fine though. Running and stopped, they sound more like opposites of each other. Oh. I feel like I should. Actually, I had my audio settings kind of funny. Figuring this out. Okay, so you got status running, status stopped. Now we should be able to remove it from here. Yes. And look at this. Say when we run, say when we stop. Yeah, we're doing all that. So honestly, I don't even think we need I don't think we need to do anything special when a connection is established. Because we're really just broadcasting to all of the listeners, which will probably just be one. So that should work great. For the time being, we don't need to worry about like auth. We don't need to worry about that kind of stuff. Because this is all just like running on our home network, hopefully in a way that like the router makes secure. Okay, yeah, let's give this one more try. So now we expect running and then the blocks and then stopped, and we expect them in the correct order now. Reconnected, hit run. Running, current, and stopped. Awesome. Yeah, it worked. So, okay, the back end side is looking good, and the front end is just logging it. So let's actually do something on the front end now. Front end, back end, right? Let's see. So here's what this looks like in React land. Calling use effect. We create the connection. So when we connect, we do something. Currently nothing. When we receive a message, we just log it out. We do need to clean up after ourselves. Oh, actually, I guess we don't, because we're doing closure capture. Socket exists there. I think we need to save socket into a reference so that we can properly clean up after it. No, probably not, because it's the whole life cycle of app. So I think we're good, actually. Maybe I'll find out I'm wrong. Let me know in chat if I'm wrong. Okay. So when we receive a message, I think at this point, we know more about the types than socket.io does at this point. So I think what we want to do is we actually want to duplicate this between the front end and back end. Currently, we don't have a good way for like shared code. I think we should wire that up later, but that's like less interesting for the purposes of it. So we're gonna copy paste this, keep them in sync, and then we're gonna say event equals data as interpreter event. Whoa, that was... There we go. So I've done my cast, and now we can handle it. That's gonna look different depending on the type of. So let's do this. Oops. I was writing in a different language earlier today, so I'm confused. Case. And look at that, TypeScript is telling us what we can write. And at this point, we know that we've started running. Like, set it to say running, running ... I don't know. Yeah. Status stopped is kind of the same thing. And then current block to highlight the current block in the workspace. Cool. So I think these two honestly are going to be easier. So let's do that first, and then we'll be able to get to this one. We only have two statuses, like running and stopped. I'm thinking we could just do a Boolean for that for now. So let's just say is running, and then set is running, and that's going to be a use state hook. Subtype Boolean, and we initialize it to false. Here, we can say set is running true and break. Actually, we can return right out of this, and then set is running false. There we go. And you know what? While I'm thinking about it, unhandled event type. Actually, this should be unreachable, but I mean, actually no, TypeScript won't catch that for us because TypeScript doesn't force us to be exhaustive with our cases. So yeah, we may need to have this. In other words, like, I don't have to have this case statement, right? I intend to, I want to for what I'm doing here. Yeah, like TypeScript itself isn't going to enforce that, so I'm going to throw an error in case I forget something. Okay, so we're doing that. We're not actually doing anything like is running. So let's pass that into our top bar. And so here is top bar. Got our run button. Here, using emotion for CSS and JS. Cool. Here's run right here. So we just need to swap out stuff. So is running is Boolean. Is running, whoops, running and on run. So then we need to say running else run. Here we'll do dot dot dot. So that's fine. Yeah, let's give that a try. Server's still running, hasn't changed. Should refresh. Actually, we have to refresh it for this on. See the light change. We should see this button change its text. Yep. Everybody sees what went wrong, right? So we hit this case statement when there's a current block. We don't return or break, therefore we hit this. So we're just gonna say return for now. Good times. Oh, what? So event is a never type now. Oh, it's because event is of type this, which is not like guaranteed to have type. Yeah. Let's see, can we do this? Or I guess we could do won't even let us do. I mean, I could coerce it, I believe. Does that work? No. All right, I'm gonna be lazy. We'll just we'll inspect it. Okay. Turn light on. Off. Run. Running. Light turned on, light turned off. And it switched back. Awesome. Okay. So now we just have to highlight the current block. Let's go back to editor. Here's editor.ts, tsx, whatever. One of the problems that we're going to run into here, where is it? Workspace.highlight block. Notice how I just threw this in as kind of an experiment. I think this ID actually doesn't exist in our current initial XML. Here, I guess we could do it like this. Just kind of show what it does. Yeah, there you go. Highlights right like that. But we are kind of switching, like we're going from the imperative world of receiving a message to the declarative world of React. So we're gonna have to do some synchronizing. It's a use effect hook, essentially. So let's import that. We'll call use effect right here. So we'll say current block. We'll pass in. Let's call it current block ID actually. That one will go up here. This should be of type string or null, because you might not have a current block. Okay. So then we need to call this effect whenever current block ID changes. But we also need to do it whenever the workspace changes, and we don't have a reference to the workspace at this level. So we need a state hook so we can store it. The problem is that I believe the Blockly editor doesn't give us a reference to it. We only get it like right here. So I think what we could do is we could actually just like in here lazily set it. I think that should work fine. Space, set workspace. And this is going to be of type workspace, SVG, or null. And it defaults to null. So then we can say, every time the workspace changed, we can say if not workspace, and set workspace to, and now we've shadowed. So let's actually rename this. Okay, so every time that changes, we haven't already set it, boom, we'll set it right here. And then this highlight block belongs in here. This should just be workspace now. You know what I'm going to call this? I'm going to call this like changed workspace. I think that kind of clarifies it. I'm going to assert that it is true. Actually, no, it might not be true because we might end up like doing a weird thing. So if workspace is truthy, then call highlight block on current block ID. So I think that's actually incorrect because highlight block actually I remember reading that in the docs. Yeah, it's right there. So their types are wrong. Luckily got it wrong. Renewable. Here's one way we can fake it. If we get a null, it's totally not a string, but at that point it's at runtime. I feel like maybe that's a little too. Let's see. What I'm thinking of doing is kind of explaining it this way. Blockly's type is incorrect. Or maybe we'll say like working around Blockly's incorrect type. Okay, so if the workspace exists, we'll do some type checking or some type coercion testing, and then we'll highlight it. Okay, so we're setting the current block ID. Now we just need to actually send that in. So you'll notice it's already planing. And current block ID, set current block ID is a use state of string or null, right? Default it to null. Let's, and actually, current block ID to event.id. Yep, that's correct. And then I'm noticing how when we've stopped running, we want it to go away as well. Maybe what we actually should do is just emit another event from the server. Let's see, where'd our server go? Here's the interpreter. So currently we only emit that when we actually have a current block. We could change this to string or what's cleaner? What do we like better? I mean, we might introduce the idea of like pause. So if we do that, then maybe be like more clear on what the current block is. So I kind of like the idea of emitting another event and then making it nullable. So let's see, that would go here. ID is null. Cool. That means that we need to change this. And now that means that this doesn't need to cause that second side effect of setting the current block ID. I like that. Okay, I'm gonna format because that's a little long. Eventually we'll set it prettier. It'll be awesome. Okay, save everything. We did make a change to our server. Run. Refresh the client. On. Okay, the moment of truth. Oh, awesome! Right here. And you know what? We'll do like, I don't know. We're gonna get crazy. 5 seconds. Change the color. For another 5 seconds, we'll do 2240. Blue, red, blue, and then off. Let's do it. Okay. Red, we're waiting. Yep. Blue, we're waiting. And we turn the light off. Awesome. Okay, I think that really adds to this because it's a lot. Like it really connects what you're looking at here and what you're actually experiencing with the light. So that's awesome. Okay, I think this is a commit. So let's get this cleaned up. And we can go from there. So we're definitely handling running at this point. So I think we can clean up all this stuff. I guess we can keep the response body from the server. It's gonna be like your program. I think we don't really care about the connection. Double check editor if there's anything you want to change. It's all cleaned up how we want it. Top bar, right? We're showing what. Then yeah, let's look at the back end. Create our socket server. Pair up our interpreter. interpreter here. Got some interpreter events, event listener. There's a bit of indirection here, but I think it's kind of nice because it makes it clear like what we're supposed to call. I guess we can make it private, right? That'll be good. Yeah, I think I want everything. I'm gonna tweak the formatting on this. Yeah. And yeah, the environment. Okay, awesome. So let's check in some stuff. Just gonna add the package log without looking at it. So add socket.io. We add the event listener to the interpreter, emit some events. Well, create the socket server. This is core stuff. That's not going to matter in production. We can rewrite that when we're ready to actually generate a build for that. This is kind of just creating noise that we're not interested in. So I think we can. Oh, hey, we actually want to say get add patch in this directory. We're setting up the event listener. Okay, so that's all the server stuff. So we've got the socket.io client. And let's see, we've got some state, socket, handle messages. Good. Pass in some state. Keep track of the current block ID. Change the text on the running button, run/running button. Okay, and that's everything. And we're gonna call this update UI, or maybe like implement socket server update UI state from interpreter events. Okay, there we go. Let's see, for posterity, grab this really quick. So here's the repo. So just put that in chat. You can find this in the YouTube video later when it gets published. But yeah, that is published. We are making good progress. And we got to do this. We got to check this out. Safe. Feels good. Okay, so let's zoom out again. Highlighted blocks. We're able to like push state changes to the UI from the server, so that's great. Now we want to go back and look at the blocks. We're ready to start thinking a little bit more about what that interface really looks like. How do people want to interact with the block? You know, where do they start and end, right? So let's dig into that. So I don't know if Excalidraw is going to help too much with this. I think we probably just want the Blockly developer tools. Bookmarked. And let's see, I remembered all my stuff. We're also not going to need, well, we might need this later. We'll see. So let's see. Here's what we have today. I think what I would really love to have is like set the color to, and then you just drop in a block. But then you could have like a simple color block where like maybe there's a little like palette you like click somewhere to like choose. But then maybe it could also be like build up a color from its component parts, right? Like H, S, and B. And when you combine all of those, boom, you get a color. And that lets us do like mathematical stuff. So you could be like, pick a random hue between 0 and 360, right? Anywhere on the color wheel. But then like saturation is 100, brightness is 100. And so create a color from all of that. And I think if we build it that way, it'll let us get really powerful about like where colors come. So let's see, we do have like set color over here. This is pretty similar, right? Set color to these values. And we could plug in HS and B. I guess what I'm proposing instead is like this whole thing would be a block. The other reason why I think it makes sense to do that though is because there's actually another parameter we haven't exposed yet, which is the transition time. Like in order to go to this color, how long should you take? And I think we want that granularity because it's really nice to like slowly morph between one color and another. Right now it's just hard coded to 1,000 milliseconds. So I think we should change that. So, okay, let's just start kind of fooling around. So I'm gonna say color, simple. We need a dummy input. And then I think, yeah, it actually has the concept of a color picker. That. And like, it's probably RGB, so we'll have to like convert it. And eventually, I think we'll want to like rewrite this with our own fancy color picker that's maybe a little bit more like Photoshop, where you got like sliders that you can move around. For now though, I think this is awesome. We can do a lot with this. So, let's see, we just need this to be input like this. Pick a cool color for the color. Oh, dog. The green background. I think that we don't need to stress so much about like the colors of these, because eventually we can like really get fancy with the theme. We're gonna switch Blockly renderers. We can pick maybe from like Google Material UI or some other like really nice color palette. For now, we're just kind of differentiating. Now, another thing that we can do though, notice how there's this output type. I would actually like to say that this is of type color. That way, we'll be able to prevent people from plugging in the wrong type of block. It just won't snap together. And so that'll help people then. The color 2, and then it would be let's see. Disconnect this. And now we need value input. Its type is going to be color. Give it a name. it's like set color to that thing. Save that. And then that would plug into that. Let's actually export this and we can try it out. Editor. Click out. UI/define blocks. Where is everything? Blocks TS. So here's set color. We're gonna all right, let's see. We got set color simple. Put it there for now, I think. You'll notice, I'm sure you've already noticed by now, but we've got this like spelling mismatch between like British style and American style. It's okay. It'll be okay. Okay, so we've got color simple. Now we need to actually reference it in the editor. So let's put here. And then we need to replace set color with our new implementation. So here's that. Do a little bit of TypeScript conversion. And then I think we're ready to see that now. Come back over here. Yeah, and now we can say, wait a minute, that did not update. Oh, look at that. You gotta delete the other one. Otherwise you just write over the top of it. Okay. So we can say set color to. Nice. And we don't have any other input style blocks. Right? So what if we like choose a color? Yeah, I mean that should. I wonder if we want to say like color : that, you know? Like it's, I can't even say it's terse, there are 0 words, but like it doesn't really like explain itself. Say color : that. And all we really did was add this. So we just put that there. So now we can say, oh, whoops, not that one. Set color to this. Yeah, something like that. I think we can test this with users and say like, hey, do you like how it reads? And we can like tweak wording, but I think this is how we want it to plug in though. Okay. So now let's check out this one because it's like set color to H, S, and B values. I think we want to recreate just this stuff as its own dedicated block. So let's start with, we can start from color simple. Oh, whoops, yeah, I did forget. Color, cool. Okay, now, whoops. Here's a fun trick. You just rename it and it's ready to save as something. Do that. I think we want to say color. And now we need several value. And let's see. A H S this looks really funny, so let's change this to inline. Go. And maybe we should actually say color from components. But from components, H, S, and B. Okay. And then we need to lock down the types of each of these to number. Number. Awesome. Yeah, I think that's finished. Maybe we should call this color from components. I don't know. We can be terse about it. I think this is just a save that. TypeScript conversion. And now you'll be able to see that here. Oh, guess what? We have to put it here. Yeah, there we go. We've got like this color or this color from components. Great. Okay, and then let's actually see some math, right? We got colors timing. Let's add it down here. Name is math, and then blocks is an array containing. And I want to say that it's just a number. I'm going to try this. I might be sorely disappointed. I'm sorely disappointed. Okay, here's what we're going to do. GitHub Blockly. See if we've been there. Oh, this file that we have landed on is ginormous. So let's just go to Blockly first. But if we dig through the source code of Blockly, there's a bunch of built-in blocks. Yep, math number, that's what we care about. And so we can actually just reuse this one and it'll work awesome. There might even be some other like math arithmetic and stuff like that we can really just reuse. There you go. So this is cool because then we can say color from components 0, S is 0, B is 0, right? But then we could be like set the color to this, and we'll do I don't know, we'll do green, right? Boom. That is coming together. Obviously, like, these are pretty simple right now, right? But eventually we'll be able to do really powerful things like, you know, choose a random number, right? Or maybe like reference a variable. So up here, we would say like set a variable, do some logic to make changes to the variable, and then we would reference it here. And we could like go through a loop where it like slowly changes colors, or maybe like bounces around between a range, whatever. There's like all kinds of stuff we could do. And this is kind of the foundation. Cool. Okay. I I know the previous stream went kind of long. I think it was around the 2-hour mark. I think it's gonna be a good idea to kind of end this a little sooner, because I think we made good progress. This is looking good, and having the current block working is awesome. So I'm excited about that. I'll probably get this cleaned up, and I'll actually like do a little bit of work to implement the evaluation. We can talk about it. But yeah, I think this is a good session. So yeah, thanks very much for tuning in, or for if you're coming to watch this in the future, for watching. And yeah, we'll see you next time. Thanks.